Good evening, everyone. Am I audible? We'll wait for 2 minutes more. Then we'll start. Is my screen visible? Anyone please respond. Yeah. So today's topic is statistics for machine learning. As I told that statistics and probability, these two topics are very much important for to learn machine learning. And these four parts expected, these four topics of machine learning, that is the most used that is the most used topics in statistics, most used topics of statistics, where we use these things in machine learning. These are expected value and mean, and variance and standard deviation, covariance and correlation, and covariance matrix. From these four topics, two first topics you all have learned in your class 2 level, that is expected value and mean and variance and standard deviation. That is in your statistics and probability chapter. So go I will go through just I will go through the theory part in a short way that you can understand it. Then I will go for code, how to code these statistical terms using NumPy and NumPy array and NumPy mean. So the expected value means you can say that the expected value is mean also. The expected value is denoted by E in third bracket X, and we can express it in this form uh, in probabilistic way, that is Pi and Xi. Okay, or you can in weighted average. That means if I give you an example that there are total n number of samples, x1, x2, x3, x4, x5, and let's suppose x1 samples have frequency f1, x2 samples have frequency f2, and likewise xn samples have frequency fn. So what will be our expected value or average, or you can say mean? That is summation of fi xi by summation of fi. And if summation of fi equals to n, so fi by summation of n, sorry, fi by summation fi by n, that will give us probability of every outcomes. So that's why it is pi into xi. That is the expected value. The next one is if our outcomes are unbiased. That means let's suppose we are throwing a dice and the dice is unbiased. So the probability of coming every outcomes 1, 2, 3, 4, 5, 6 is same 1 by 6. So the pi term will be constant for every outcomes. That will be 1 by n. So it will come out and the expression will look like this. That is px summation of xi. Okay, and this is the form that x bar equals to mu equals to ex, that these all are same, mean, average, and expected value. Now I will go to the code part. I think this is clear to all of you because these are the basics thing, because these are the basic thing that you have learned in your class 2 level. So I think I don't need to explain it in more deeper way. I think you can understand the average, mean, and expected value. Okay, so how to code it in Python? Here we will use a library called Numpy. Using Numpy, we can create arrays, we can use arithmetic operations and many operations with arrays. Yeah. So we'll import Numpy, import Numpy as np, and let's create a Numpy array. I think you all are you all know about what is array. Array is, you can say in other way that array is a vector, is a 1D vector. It can be 2D vector, it can be 3D vector. Okay, in mathematical we can say that. So let's suppose we are making an 1D vector, or you can say 1D array is np array. So 1, 2, 3, 4, 5. This NP array, this NumPy array has 5 elements. Okay, has 5 elements. And if we print this array, so it will look like this. This is a list. What I pass as an input is a list, and what it is giving a NumPy array. If I want to know the type of NumPy array, we'll write type function. Inside that type function, we will give v. So you can see that it is numpy.nd array. Nd means n dimensional array. This is one dimensional, so it is 1D array. Now uh, I will want to calculate the mean of this array, or you can say the expected value of this array. Okay. So let's suppose px is equals to np. There is a function in numpy that is mean, and inside this function we will pass the numpy array that will give us the expected value, that is x. You can see this is the average, or you can say expected value. So if you want to know it in a better way, that you can understand it, that 3 is a middle value of this array. That means you can say that 3 is the middle ranged value. That means around 3, every the elements of arrays are the elements of arrays are around the value 3. This is actually the mean is showing to us. Now I will go for standard deviation. I think mean and average, this is clear to all of you, that how we calculate this using Python. Now we'll come to the variance and standard deviation. Variance and standard deviation is nothing but the deviation of every samples, sample inputs from the inputs average. That means, let's suppose that what is the difference between 3 and 1, 3 and 2, 3 and 3, 3 and 4, and 3 and 5. So we are calculating the average deviation. That is called variance, and standard deviation is nothing but the root over of variance. Or you can, in machine learning, we termed it as sum of squared error and average of squared error. We will learn in future. So variance is denoted by var x, and this expression of variance is var x equals to, this is the expression, the expected value of x minus expected value of x. This x is inputs, and this is the average of all inputs. Okay, and whole square. So this is the sum of squared, average of sum of squared error. And we can write this in probabilistic way, that every error has some probability of existence. So this is the pi into xi minus average, the expected value of x. And if our outcomes are unbiased, that means, just like I gave you example, the throwing a dice, throwing an unbiased dice, then our probability of every outcome will be 1 by 6. So this probability pi will be constant for every error. So this will come out from the summation. So 1 by n summation of xi. This term you can read here. So we can express it like sigma square and variance of x like this, and the standard deviation we can express it like this, the root over of variance. I will come to the code part, that how to code variance and standard deviation in Python. So as I told that we have to import array, then we have to calculate the variance. Uh, Let me give you a real-time feel, that is why we will calculate the variance, or you can say the standard deviation. Uh, when we will train our machine learning model, just to know the efficiency of that model, we use variance and standard deviation. In linear regression, as I told, that in a linear regression, we termed this variance and this standard deviation as mean squared error, or you can say the sum of squared error, that we will learn in future. Okay, so now let's import numpy. Once we have import the numpy, we don't need to import it again. So just we import the variance from numpy. Let's create a 1D uh, vector, that is np dot array 1, 2, 3, 4, 5, 6. So we want to calculate the variance. So var is equals to numpy dot variance. So numpy has a function called var. We will import that, and we will pass the array, and ddof is equals to what? So you can ask me that what is ddof? Ddof is a unbiased error. This is a statistical term when we express this variance in more deeper way in probability distribution, then we will get plus minus one error. So that is called the what I said, that is called the unbiased error. So this is the one. So this will calculate the variance. So variance of this data set or variance of this 1D vector will be 3.5. And also we can calculate the standard deviation also. Okay, before going to standard deviation, I would like to calculate the variance for 2D array also. Okay, this is for 1D array. I calculate for a 2D array also. It's called V1, and I will define another variable V2 v dot array. Okay, so 2D 1, comma 2, 3, comma 5, and comma 6, comma 7, comma 9, comma 9, comma 0. Okay, this is 2 cross 5 dimensional array. Now I want to calculate the variance of this array. So if we print this V2, it will look like this. Let me comment it first. It will look like this. So now we'll calculate the variance. We can calculate the variance in column variance. There are two types of variance for 2D array. That is column variance and one is row variance. First, we'll column variance. Column variance will calculate for 1627384950, and row variance will be one this vector and for this vector. So first we'll calculate the column variance. So column var is equals to, we'll define a function. Oh, sorry, we'll define a variable column var and import the var function from numpy. We'll pass our vector 2D vector, and unbiased error is equals to 1 and axis is equals to 0. And what is axis equals to 0? Axis equals to 0 means it is telling this code that we want to calculate the column variance. We want to calculate the column variance. So if we write this call var, so you can see that there will be total 5 column variants: 1627384950. This column variance. Now we'll try row variance. Row variance equals to np dot var. The same thing, I will copy it from this. Here axis will be 1. So it is telling this code that we want to calculate the row variance.
One question can I ask, Aniket?
Yeah.
Can you just explain what is this DDoF?
DDoF is a unbiased error. One
Okay, okay,
here in you can see here that there is a probability uh, term that is 1 by n, where it is unbiased. When our outcomes are unbiased, we will the probability of every outcomes will be 1 by n. But if our
yes.
outcomes are biased, then there will be a term that n minus 1 or n minus 2, that we have to calculate. There is a mathematical calculation that is not, that is the mathematical part, so I'll not go for that. Just
Okay,
here I am showing that how to calculate the variance through Python. Okay.
okay, okay, okay. Not carry on.
So here you can see that there is two row variance, because there is two rows. For one row, for first row, this is a first variance. For second row, this is the variance. Okay. So this is all about the column variance and row variance. So I have completed two parts. One is expected value and mean, and the one is variance and standard deviation. And I think you have understood that how to code it in Python. Now we will come for covariance and correlation. So what is covariance and correlation? If you completed your second sem in proper way, then you all know about the covariance and correlation that our mathematics professors have taught us. But I will explain it again. So first of all, what is covariance? Actually, covariance,
Aniket, your
what
screen share
covariance
has
do?
stopped. Aniket, your screen share has stopped. Can
Oh,
you check?
just a second.
Yes, yes.
Now is it visible?
Yeah, now it's visible. Continue.
Okay. So what covariance do? Covariance uh, helps us to know the relation between X array and Y array. That means X and Y array, they are linearly dependent or inversely dependent, or they are independent. If you study probability in a proper way, you all know about the independent independent event and dependent event. When there is an independent event, we define that P A intersection B is equals to P of A into P of B. Here, we using covariance, we will try to understand that there is if there is two data sets, suppose X and Y, uh, they are dependent or they are independent, or they are linearly dependent or they are inversely dependent. That means maybe X array they are increasing and Y array is decreasing. So they are inversely dependent. So covariance will be negative. So through the uh, result of covariance, we can understand the relation between two array. So this is the expression of covariance. That is the average of uh, the deviation of x from its average into deviation of y from its average. So this is the covariance of x and y. Okay. And if, as I said earlier, that if we do it for unbiased data set or unbiased event, then the probability term will come out from the summation part. It will be 1 by n, and the difference between um, the value from its average and y value from its average. So here I have written the three things, that if covariance of x and y is positive, then x and y are linearly dependent. So it will showing that the array elements of x is increasing, and side by side the array elements of y is also increasing. Suppose x has 1, 2, 3, 4, 5, and y has 27, 39, 48, 56, and 67. You can see that the elements are gradually increasing. So there the covariance will be positive. It will give us a positive term. And when we see that x and y array are inversely dependent, then covariance will give us negative value. Like x elements are 1, 2, 3, 4, 5, and y elements are 9, 8, 7, 6, 5. So they are inversely dependent. And if covariance is 0, then x and y are independent. Then probability of x intersection y will be probability of x into probability of y. And when we standardize the covariance, we will term it as correlation coefficient. That is R. R equals to covariance of xy by standard deviation of x and standard deviation of y. Okay, now we will come to the code part. And in machine learning, where we will use it, use these things, I will show you later. Now come to the code part. How we will code this thing in Python. First of all, we cannot directly um, you know give us the output of covariance. We have to first make covariance matrix, then then in 0 and 1 position, then in 0 1 position the element will be our covariance of xy. And I think you can't understand this. I through writing code, I will try to make you understand. So first of all, as I imported NumPy array, so I have to import the from NumPy. I have to import standard std from NumPy. Okay, from sorry, we have to first make a array and an x array and a y array, and find out the relation between x and y. 1 comma 2 3 4 comma 5. This is the array. This is you can see this is a gradually increasing array, and y is equals to 5 comma 6 comma 7 comma 9. So as I told that the covariance of x and y should give us a positive value. So let's see, is it giving it or not. So cov is equals to np.cov. There is a function that will calculate the covariance x and y. Actually, this what I have written here, that np.cov, this will return a matrix, that is covariance matrix. After this covariance, I will explain this on also. And this matrix, in this matrix part, the 0 1 position element will be our covariance. So we'll set the position 0 1, and this will give us the covariance of xy. So you can see it is giving us positive value. So through this value, we can understand that these two arrays are gradually increasing. They are linearly dependent. Okay. So if we make it in an inverse order, 9 comma 8 comma 7 comma 6 comma 3, it will give us negative value. See, it is giving us negative value. So through this, we can understand that this x and y are inversely dependent. While x is increasing, y is decreasing. Okay. Now we'll calculate the covariance. We'll calculate the correlation coefficient. COR is equals to NP dot correlation coefficient. Actually, when we'll try to standardize the covariance, we'll come up with a correlation coefficient. That is here it is giving us minus 3.5 value, minus 4 point. It may give us like that value, but correlation coefficient will bound our limitation from minus 1 to 1. If x and y array are linearly dependent, then correlation coefficient will give us plus 1. If it is inversely dependent, then correlation coefficient will give us minus 1. So x comma y 0 comma 1. We'll print the correlation coefficient. Here you can see that it is bounded in minus 1 to 1. So the value is coming in this range. It is 0.96 minus, because here I have told that this x and y are inversely dependent. Okay. Now we'll come up. We will now I will explain the covariance matrix. Covariance matrix. It's a bit hard to understand now for this moment, because uh, you have first of all I have to explain the feature, the thing of a thing feature that is a, a important part in machine learning. Like I'm giving an example that I want to predict the price of some the price of some area. Okay, so we'll calculate the diameter, we'll calculate the size of this area. So the size, diameter, these things are features, and based on features we come up with labels, that what will be our price, what our price can be. Okay, so x and y, x and y are denoting those features. Like I want to predict uh, that a patient has diabetes or not. There will be some features: the sugar level, blood pressure. So the sugar level, blood pressure, these are the features, and based on those features I will tell that the patient has diabetes or not. If there has diabetes, uh, the machine learning model will return 1. If those patient had no diabetes, then the machine learning model will return 0. So here the x and y are those features, and we want to, and now you can understand why we want to calculate the covariance and correlation, because we want to know the relation between those features, that those features are linearly dependent or linearly independent. Here we use the concept of probability and statistics, which we have learned in our class 11 12 level. So you can see that the at 0 0 position, the covariance is calculated if there is two features. With the in 0 0 position, our element is covariance of x and x. In 0 1 position, it's x and y. In 1 0 position, it's yx, and in 1 1 position, it's yy. So in our previous part, where I was explaining, covariance and correlation. There I told you that uh, we if you want to calculate the correlation coefficient or covariance, we have to uh, write this one also, that 0 1 position. Now you can see the this matrix, because in this matrix in 0 1 position, covariance of xy is defined. Now I will do the same thing. Now let's suppose we have now come to the code part. uh, we have defined x and y, two arrays. Now we want to print this matrix. Okay, so of matrix, covariance matrix equals to np dot co. As I told, that co will return covariance matrix, but when we write this one also, this in this third bracket 0, we are defining the position x comma y. This will give us a 2 cross 2 matrix. Okay, so this is cov. See, here it's cov. See, in 0 1 position, in this covariance matrix, in 0 1 position, what is it written? This is written minus 3.5. What is it? This was covariance of x and y. That's why we there we write the code in form in bracket 0 comma 1. Okay, so this is the covariance matrix. Using this matrix and using this covariance and correlation, as I told, that we are finding the relation between some features, and they're all set. These four parts that are very important for machine learning, I have explained everything. If you have any doubt, you can ask me now, and I will share this IPyNB file in PDF format in our group. There you can study this. Now you can ask me if you have any doubt. if you have in doubt in coding part, that if you have in doubt in theory part, you can ask me. I will provide some PDFs also that may help you to learn all these things. I think there
Hello,
was no
Aniket.
doubt. Huh.
Uh, uh, why you why you put the value of DD of is one in?
Okay,
Hmm.
let me see. See,
Yes, yes, yes. Hmm.
actually, DD of one is a unbiased error, or you can say unbiased estimator. If you put that for normal distribution, we use that DDOF. We use that unbiased estimator. Okay, because because in a real condition, no data set are unbiased. No data set are unbiased. Okay, actually I want to mean कि मैं हिंदी में बोल रहा हूँ, ठीक है। देखो, एक्चुअली रियल वर्ल्ड में क्या होता है, जैसे होता है ना, वो रियल गैस होता है, और एक होता है तुम्हारा वो एक्चुअल होता है तुम्हारा, क्या उसे कहते हैं, बोलो ना, जो सब कंडीशन को तुम्हारा फील करता है। केमिस्ट्री में था वो, बोल
फील
रहा
करता है।
Ideal guess, I think.
हाँ,
Real guess or
आइडियल
ideal?
गैस, आइडियल गैस, रियल गैस, आइडियल गैस। जैसा जैसे कि रियल गैस रियल ऑन में, तो जैसे कि आइडियल गैस रियल ऑन में तो नहीं हो सकता ना, सब कंडीशन आइडियल होता है। तो उसी तरह से हमारा जो हम जो डेटा सेट लेते हैं वो मतलब बायस नहीं हो सकता है, कुछ ना कुछ अनबायसिंग एरर उसमें रहेगा, और उस एरर को फिक्स करने के लिए हम डीडॉफ को यूज करते हैं। इसके बारे में मुझे भी बहुत सारा नहीं पता, क्योंकि इसके पीछे एक मैथमेटिक्स है, वो एक्सप्लेन करना पड़ेगा, तभी जाकर तुम उसे डिफाइन कर सकते हो किस तरीके से हम लोग मतलब नॉर्मल डिस्ट्रीब्यूशन से माने मतलब वेरिएंस को नॉर्मल डिस्ट्रीब्यूशन में कन्वर्ट करके हम लोग को डी ऑफ को निकाल सकते हैं। यहाँ पर 1/n-1 आएगा, ठीक है। एक्चुअली क्या मैं इसको करूँ, इसका एक्सप्लेनेशन मेरे बुक में है, मैं वो दे दूंगा ग्रुप में, तुम पढ़ लेना वहां से। If I will set it d of is equals to 0, it will give us a biased value. If it will give us the unbiased value correlation. You can set it 1, you can set it 2. This is an unbiasing indicator. This is some errors. In ideal condition, we will set it as 1. Okay? Yeah. Anyone else? Okay. So let's stop this session here. Thank you for joining.